over the check your understanding questions from the slide note packet talking about the military jet that's flying at a uniform 9.3 times 10 to the 2 meters per second south. So just to kind of go over a few things, I'm entering in that information over here in my sheet. So velocity, meters per second. In this case, I put the south, but really don't need to have that in there on the label part, so I'm just going to get rid of it. They give this to me in scientific notation. Now, how you enter scientific notation in Sheets or Excel is you enter the number, and in this case, it's 9.3. So I enter 9.3 and then capital E without a space between the letter and the number, and then positive 2. Now, I put a negative there because negative is south, and that is in the negative y direction. So if you kind of look at your compass here, north is in the positive y direction, east is in the positive x direction, according to the xy axis. So that's the convention that we want to use. Again, this has it as negative for the direction, 9.3, capital E, no space between the number and the letter, positive 2 because it's a positive exponent. You need to put the positive there. If it was a negative exponent, you could put negative. Now, over here, I just wrote the number out because the exponent of 2 is easy enough for me to just write that out the long way. Now, there's a reason why I'm putting this velocity information over here in Sheets. This table is going to do calculations based on that velocity. Now, you could enter a formula where you put the formula in there and you put 930 in the formula for Sheets. However, if I copy and paste that into these other cells, what it's going to do is it's going to use 930 for each one of the calculations, whereas I want it to use whatever the velocity is in this cell over here, which is C2. The reason for that is all these answers are based on whatever that velocity is that I entered there. So isn't this graph. Now, what if I give you another problem, and the problem, instead of a velocity of negative 930, the velocity is negative 400? Well, I'm going to want everything to update based on that change instead of having to go in and change the individual formula and copy and paste it, etc. So now that I've changed it there, when I hit enter, all these factors should update and the graph should update. Okay, and you can see it is updated and the graph did change. What if I go in there and I make it a positive 200? Okay, so now we have a positive slope. So you want to make sure that when you create your sheets and your tables and so on, if there are values that you might change and then need to get updated in your table, you should put those values somewhere else and then have the table reference back to that individual value. So let me just change this back to 930 and show you what this equation formula looks like in Sheets over here. So when I click on this cell that's highlighted in green, you can see that the formula says equals $2 times F4. That $sign right in there is kind of like an anchor to that cell. Right? So if I go to this next cell right here, which is G5, it's still calculating it based on C2, right? And if every time I go down here, all right, it's going back to C2, right? It's using C2 times F6 and so on, right? So it repeats the calculation using all these other F values, but it always goes back to whatever this value is here because I put the $sign into it. Okay, so the equation to figure out displacement or change in position is velocity times time. All right, so the velocity of the plane is 930 meters per second in the negative direction, and the time change is 0, 1, 2, 3, up to 12 seconds. So I'm just going to be doing that velocity times those time values to figure out where the jet is in relation to the starting point, which is the mountaintop. Okay, so it starts at the mountaintop and it flies south away from it. So in the first second, it's traveled 930 meters south. In the next second, another 930, and so on. Now, to plot that, it would look like this, okay? Nice linear relationship because it's constant velocity. It starts here, which is the origin for the position, and it goes in the negative y direction, which is going west, okay? And there it is at 12 seconds, all right? And if you click on the point, it tells you position negative 11,160, which is the same value that we see in the table right there. Okay, the next thing they want us to do, oh, and here's the equation of the line right up here, right? Negative 930x, the negative 930 is the slope, plus y intercept of 0 because it started at the 0 position. Okay, so the next thing they want us to do is take that information and plot a velocity time graph for the plane's motion. Okay, well, velocity is the change in displacement over the change in time. Okay, so this table right here is going to reference the values from the other table. Okay, so right now I have my formula highlighted under my velocity cell. So the formula is G4 minus G3 divided by F4 minus F3. Now those things have to be in parentheses so that it carries out the correct order of operations. So what is it doing? It's taking G4, which is negative 930, minus G3, which is 0, divided by the time change, which was this time, 1 second, minus 0 seconds. Okay, and then it's going to repeat that for all the values. Okay, and in this case, we're always going to get 930 because we know it's a constant velocity. But if this graph over here had a curve and there was changes in velocity, well, then I'd have, it would show that. It would show a change in velocity in my table. All right. Now, the graph should just be a nice straight line, horizontal, flat at that value, which is negative 930. And that's what we got. If we figured out the area under here, we'd have negative 930 times 12 seconds. Negative 930 meters per second times 12 seconds gives us 11,160. I should put a negative in there. Let me fix that right now. Negative 11,160 meters. That area represents the total displacement. And when I check on my chart over here, it matches.